Okay guys, I'm going to try to do this on my camera because I'm not at school and I don't have access to anything better than this. So this might work. Okay, we're going to do a dihybrid cross. The dihybrid cross is going to consist of a plant that would produce yellow seeds, but it's a heterozygous. It's heterozygous for yellow seeds, so it's big Y, little y. And it's also heterozygous for round seeds. So it's going to be big R, little r. And we're going to cross it with a plant that has the same genotype. So this plant could either be self-pollinated or you could cross it with another plant with the same genotype. So big Y, big R, little r. So the first thing that we have to do is figure out what the gametes are going to be. So I'm going to put big Y, big R, little r. And if you'll all agree, since this one is the same as this one, we're going to have exactly the same gametes. So the first thing that you do is we're going to have part of our gametes are going to be big Y, big R. Part of our gametes will be big Y, little r. Part of our gametes will be little y, big R. And part of our gametes will be little y, little r. Like that. So we have 4 different types of gametes. Now, when we have a dihybrid cross, if you remember a monohybrid cross, it looked somewhat like a tic-tac-toe board. Like that. Now a dihybrid cross is bigger. And with a monohybrid cross, we had only 2 different gametes. With a dihybrid cross, we have 4 different gametes. 1, 2, 3, 4. So we're going to have to make enough room in our dihybrid cross Punnett square for 4 different gametes. So we're going to have 1, 2, 3, 4, and since it's the same gametes for both, it's going to go 1, 2, 3, 4, down. I'm going to put this here. I'm going to write the gametes across the top. Big Y, big R comes from here. Big Y, little r comes from here. Little y, big R comes from here. Little y, little r comes from here. Now remember, since they were the same, it's going to be the same across this side. Big Y, big R, big Y, little r, little y, big R, little y, little r. And we do the same thing with our dihybrid cross as we did with our monohybrid cross. I'm going to fill out the Punnett square. Take this box and this box and cross them, and we get big Y, big R, big R. I'm going to do the same with this box and this box. Big Y, big R, little r. And I'm going to go ahead and I'm going to quickly fill out my Punnett square, and what I would have you do is to do the same thing and compare your dihybrid Punnett square with my dihybrid Punnett square. I'm going to do it quickly here. I'm running out of room. I didn't make my squares big enough. Now what I'm going to do is I'm going to take my the crosses from my Punnett square, and I'm going to write out all the phenotypes, all the different kinds of seeds that we could potentially get. We could get, let's see, I'm going to take this and I'm going to show you, we could get yellow and round seeds. We could get yellow and wrinkled seeds. We could get green and round seeds, or we could get green and wrinkled seeds. I'm going to go ahead and write those phenotypes out. Along the side, we could get yellow and round. We could get yellow and wrinkled. We could get green and round, or we could get green and wrinkled. The way that you figure that out is you go in your Punnett square and you, like for instance, this one would be, it's homozygous dominant for each trait, so it would be yellow and it would be round. So there's one. This one would be yellow and round. 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 Ah, that one's going to be yellow and wrinkled. That one's going to be yellow and round. That one's going to be yellow and wrinkled. That one's going to be yellow and round. Yellow and round. That one is going to be green and round. This one is going to be green and round. This one is going to be yellow and round. This one is going to be yellow and wrinkled. Yikes. Oh, yellow and wrinkled. This one is going to be green and round. And this one is going to be green and wrinkled. And if I go through and count, I would have 5, 6, 7, 8, 9, 3, 3, and 1. And that comes up with our special ratio of 9 to 3 to 3 to 1. And Gregor Mendel found that ratio to be just as special as that 3 to 1 ratio that we found in monohybrid crosses. Go back in your book and read about that. Okay? I hope this works out for you. Have a great day. Bye!